Today we're talking with Alberto Rizzoli.
Data-centric AI, particularly popular topic, even probably before Andrew Young started talking about it. In general, I think the AI has been data-centric since deep learning, effectively. But there's been this transitionary period of time in which we had model-centric approaches because model architectures were just getting better and better. And we're going to go to exactly why in just a second. But I think one thing I'd like to convince you today is that a lot of the delta improvement in AI is data-centric. And this is good news for some and bad news for others. In general, what we'd like to do in one of V7's objectives is to make training data no longer be a problem for you, make it something that you can easily morph, just like a compute resource, scale up and scale down whenever you need it, so that you can actually create models that are performant. We've moved from this world in which you would tweak the model parameters a lot to get to where you wanted to go. That's particularly common handcrafted feature in developing handcrafted features in a lot of classical ML. We've had this period of time in which hardware was becoming a bottleneck because models took so long to train. Now, a lot of models in industry no longer take that much unless you're working on enormous models like GPT-like architectures. You are probably not working on something that takes more than a couple of days to train. Even ImageNet for pre-training model now takes a day or two on modern hardware, whilst 3 years ago it used to take a couple of weeks. And now the training data is starting to become the competitive advantage of a lot of companies. And one of the reasons being is that every company industry has unique objects that they need to create. And so realistically, what they're basically creating is this knowledge, this internal knowledge of what their objects look like. And currently it isn't being stored in ways that are particularly efficient for an enterprise that wants people to identify defects in solar panel production, or cancer in digital pathology slides, or cracks on the runway when planes are taking off, or the ripeness of a specific fruit. So this, I think, is where data centricity starts to take flight. Effectively, these pictures, this amount of data plus relevant labels, starts to become, in many ways, the actual core value of an AI team's resources. And this core value creates this new possibility for a centralized library of training data that we think is the bedrock for the future of a lot of ML-based software. It starts from being able to have the available training data and then using it to create models that can solve a specific task. And training these models, not necessarily by tweaking primarily the models, but by tweaking the way the data looks, the way the data is labeled, defines how well the model performs. And in some ways, the model should also tell you, not advise necessarily on how to change its parameters, but on how to change its core training data to be able to solve a task better. There is no way to make someone learn an object that isn't visible enough in the training data by tweaking hyperparameter or by changing the architecture. The easiest way, if you have the ability to do so, is to change the actual core training data. And in many ways, the bottleneck against doing so is in lack of tooling. And we've seen this evolution in the acquisition of training data in companies, both in academia and in industry for the past 4 years or so. V7 is less than 3, is just over 3 years old now, where previously you would have this exchange of annotation files. You would have companies, sometimes BPOs, produce the label data and then send it back as raw data into another repository, or sometimes just as folders via email. And this creates a ton of really bad training data. And this is actually what we are sitting on since in the academic world, we're sitting on a lot of really poorly built benchmark data sets. We're going to get to that in a minute. Then a lot of universities started developing DIY tooling, some of it which is open source. This has really big problems in project management, has really big problems in dataset versioning, and most importantly, it doesn't really have that high of an integrability. You can't really integrate it with all the other MLOps tools that are available. And what we wanted to create was a dataset management system that had these easy MLOps integrations. And today, if you are getting any of your training data created, your flow probably looks, you need to label, say, 20,000 images, and you deliver these 20,000 images labeled, you start training your models and so on, but there is no kind of continuous flow that is happening between your models being trained and being deployed in production and getting continuous labels back into your training set so you can actually improve that performance. And we wanted to create a system that was a lot more integrated so that when you have deployed your model in production, you might create many versions of that. These versions might send low confidence score items back into the data set itself. They might be able to reveal what the model actually doesn't know, where does it need to improve. And the way of doing it is to create this flow, this production loop or this production flow of AI, where once you have your model in production, you're able to send some of that raw data, which in this case is pre-labeled by a model, back into a dataset repository. And by closing this loop, you effectively have full knowledge of what is actually going on with your system in production, whether it's running in the cloud or running in the edge, like in a self-driving car. And these are some of the trickiest steps to fulfill, to send data back to a mothership, if you will, especially if you have a fleet of objects. If you have many self-driving cars or many robots, it's very challenging to know what and when to send things back, and uploading them in a way that is scalable and usable by all data scientists within an organization. So having data sets that can be versioned, having data sets that can be queried and segmented easily, and not doing so in a traditional kind of directory-based view with JSON files that are attached to images that are within a folder. This is a caveman experience of creating great training data sets. And then being able to send it easily to human annotators for correction. And that is, I think, what's differentiating teams that are truly scaling their AI efforts, especially in areas that are sort of time critical right now in competition, like driving, robotic delivery, autonomous checkouts, and a lot of the medical cases. V7 is particularly big on medical. So to take a step into what I've personally been working on and how we've tried to appease this flow is by following a bunch of product principles that we defined early on. The first one is to create a delightful user experience in the. One of the most hated things in AI is that training a model and deploying it seems sexy, but creating training data is kind of not. We wanted to make an experience that would be fun, almost gamified, and heavily automated. And that's one thing that, for example, doctors particularly enjoy, because when they are using a tool that is truly beautiful to use, they will be producing a lot more output and eventually producing a lot more label to learn from. Another one is massive scalability. We have users that have data sets with billions of labels, and these can sometimes be very, very hard to query and segment. But we wanted to be able to give the certainty to anyone who is developing massive data sets that things aren't going to break. And that most importantly, you can take a data set of, these are mammograms, for example, of 500 mammograms from one specific population and easily query them and then turn them into a test set. And then finally, being able to automate as you complete your labeling. I think this is a principle that is happening all across the industry. If you're not leveraging models as a company that is ultimately developing, you're kind of wasting a lot of your time. But the devil's in the detail on how to use effectively models to label additional data, because they tend to create these slightly crappier output that needs to be fixed by humans. Sometimes fixing takes a lot longer than creating things from scratch. So our principle in the end is make you stop worrying about training data. And I think that is one of the biggest problems in creating really efficient ML products is how do you make people not have a bottleneck in the labeling of data and in the versioning of their data and ultimately creating this library of knowledge for the model. This is actually this short clip that you're seeing is all auto-labeled. So the quality is human passable, but it is not always 100% perfect, but it is a first pass. And it's actually part of the V7 team. This summer, we went to Puglia to have a retreat. And we had this short video clip that we then auto-segmented on the platform. You can see that each person is instant segmented as a different individual, and this took only a few minutes to create. What do we mean, though, by a library of knowledge? The way we'd like to see the future of training data and the future of this component of MLOps is that it's kind of like a big library of VHS tapes. And the VHS tapes are particularly annoying to read and to query. And imagine that you can only learn about the world through VHS tapes. You have to take them out and stick them into a DV and watch the footage. But let's add an additional challenge in that you're actually an alien from outer space. You come to Earth, you need to learn everything about planet Earth, but you can only look at VHS tapes. The first thing you would want to do, given unlimited resources and magical tooling, is that you would want them to be organized in ways that are very, very easy to query, so that you actually know where to improve your knowledge. If you want to learn more about birds, if you want to learn more about driving, or about what is inside people, how does their organs function, you want to effectively create a library, and you want to have something that is easy to query. Obviously, this is a physical library. It would be something a lot more like Google search, but that can give you this training material in ways that is particularly easy to create and to segment. And most importantly, let's say that you're reviewing for your final exam coming to Earth. That's effectively when you're doing your validation set during training. You aren't necessarily always changing your brain on the fly, but you are potentially testing yourself against different sets of training materials. So you might be testing yourself against, hey, I've studied this set of material. Let's see how well I understand the world versus when I studied this set of material. And this is the principle that we're going towards now, that for the past 20 or so years, we've had variable models and variable model architectures, but fixed training data sets. And we'd like to encourage this to change, especially in academia, now that we have the tools to create more variable training data sets, because there's a lot that we don't know about how changes in training data affect model performance. We have a lot of data about, and charts about how changing minutely an architecture or adding more layers or adding more parameters to something changes the performance on a fixed data set on ImageNet. But we know very little about how the quality of label changes model performance given a fixed model or given a series of variable models. And I think this has created a bit of rot in our research community, where we still use data sets that are in some way ill-purposeful for a lot of industry cases, and rightfully so. I mean, they weren't meant for them. But to give an example, ImageNet has a lot of mistakes because it's been labeled through image classification, which is actually not something that humans are very good at. In fact, if you look at this image, this is the very first class on ImageNet. It's aardvark. And if you look at some of these images, you would question whether they even should be labeled as aardvark. For example, this one here at the bottom, not sure if you can see my cursor. To me, it's more of a shower curtain picture than aardvark. And ImageNet has only one label. So which one do you pick? You pick an aardvark because you're a human ape and you don't really see them that often. And so you think that this picture's most relevant tag is the aardvark. But in a perfectly balanced data set, then aardvark is just as common as a shower curtain. In this case, it's a shower curtain picture. Another problem here that might be obvious to some of you who are into zoology is that a lot of these are anteaters. In fact, this class is 98% wrong. It's one of the many classes with a lot of mistakes that is still being used to benchmark models on ImageNet. Not that it matters, because there isn't any other animal that is similar to anteaters, but it's just one of the more egregious examples. And we don't care about this because we humans do not care about the difference between an anteater and an aardvark. But if it were a difference between a car and a motorcycle, I bet you that a lot of companies would care, especially self-driving car ones. And another problem that we tend to do is over-supervise. In the quest of creating models that are better and better at generalizing the world, we've tried to create these fixed data sets that have way too many labels to make sense, and the labels are sometimes oddly connected to one another in a way that is yet another data set schema that becomes a new standard. And this is, in this case, the human genome data set. And I think this is also potentially a mishap that we went after in the past. So what I'd like to go after is and this should probably say 2020 plus, is a world in which we have iterative data sets and iterative models, one by the labels or even by the raw data itself, and another one by parameters. So we could start understanding the true impact of changing data sets more so than the true impact of changing the actual model architecture. And if you look at the leading computer vision teams in the world right now in industry, very few of them do not disclose what their model architecture is like. They actually showcase it with pride, and you can copy it. You can have the very same architecture running on your stack. But what they won't share with you is the amount of label training data that they have. And so our goal is to try and make that a much more open and scalable resource in a platform that allows this cross collaboration between data scientists, but also between other MLOps tools that can easily integrate with V7. More examples here of cases where you wouldn't really easily be able to label these objects. And let's say that your quest is, in this case, to identify the dragonflies or the mushroom. What's the best way to create this training data for not just any model architecture, but any industry use case? You're a company that is hell-bent in identifying the dragonfly. What's the most efficient way of doing so given images that look like this? There's a lot less knowledge and a lot more nuances related to that, and a lot of it requires actually testing things in production using various label data sets. Another thing that we see increasingly more and more is creating this granularity, especially of test sets, where it's not enough to have a very large data set that then you split. Sometimes you split randomly into train, test, and val. But to have multiple ones that test for various scenarios that you as a human care about and care to benchmark for. This is especially important in terms of AI safety, in terms of bias recognition. There's a lot of ways of identifying bias computationally, but let's not forget that in many cases, the kind of regulatory bias is still human defined, and it's a classification. And it would be nice to have the ability to easily say, hey, this car can drive on snow safely, it can drive on desert safely, but it's a little bad at identifying debris on the ground because we benchmarked it against this. And this is true in almost anything that is safety critical. In medical AI, for example, changing the MRI scanner from one model to another, or even changing an X-ray machine or something that will scan the fundus of your eye, actually changes the way a model will perform from one to the other. Even the population, if you train on chest X-rays from people from East Asia, test the model on people from Southern Europe, they'll have very different results for seemingly the same exact pathology. So wide availability of test sets and wide easiness of being able to pull them frameworks, pull them into experimentation tracking tools, and sort of making training data be more of a friend to the MLOps community, to the various tools that are available out there. And the way we like to see it is that AI is ultimately a living piece of software. You're continuously feeding it with more and more information. You're continuously updating the way it looks by architecture as there's new breakthroughs every 12 months or so. And this really requires an easy of this loop and of this flow. So where do we see MLOps components touch in the work that I've personally been doing at V7? A lot of it is in the areas that we personally touch upon, which is datasets, models, the human labeler aspect of it, and in the workflow that training data goes through, and then ultimately the annotations. But we don't really touch on to ourselves when we integrate is anything that loops, ML frameworks, experimentation, and also in many cases, the way things are stored. Some people might have their own custom cloud storage solution for all of their ML training data, in which a platform like ours would plug in. So again, this gives you an area of where we've been looking at. And here's some duplicate slides that I have. And these are some of the things that have moved the needle for us in terms of the success that our tool has had. If you're looking into kind of speeding up the performance of your ML team, the number one thing has been a lot faster labeling. And a lot of it is a psychological thing. It's reducing the fatigue of human labelers to create great training data and to leverage models that are really, really accurate, even though sometimes not the fastest. So they want to be able to run in real time on a small GPU, but by God, they are really accurate and making the same work that a human would normally do. And this is an example of our auto-annotate model that is class agnostic. So it can be run on any object and will automatically segment it no matter what it is. And it understands from these prompts that you give it based on a bounding box. And it can also respond to correction clicks. And the other part that we're seeing increasingly more and more is companies creating many different data set versions for everything that they do. Many exports of a data set, which then get version controlled. And each one of them is a different version of an experiment. So in your experiment tracking, in many ways, we see tools that just have kind of a fixed data set and then a whole variety of models. We're starting to see the other way around. We're starting to see sometimes the fixed model architecture and parameters are sometimes chosen through third-party tools that automatically pick them. And then a lot of dataset versions, sometimes without a class, sometimes by using a different set of bounding boxes that look different or a different set of tags that have a different taxonomy. And being able to switch easily between the two is just as important of a parameter tuning as it is to tune the actual model parameters. And then obviously being able to run models within this loop. It's almost an inevitable thing, especially for a lot of human in the loop cases where you have models doing the grunt work of doing some of the initial identification, and humans actually do what they do best, which is refining work and then confirming it and taking that human responsibility, in some cases legal responsibility of making a decision. Anything that related to purchases, people don't really want to know that they're being charged by a robot. They want to know that they're being charged by a human. So the best way to do it is to have the robot do much of the work and then the human approve with their kind of humanness of empathetic decision making. So say that you are a company that needs to analyze dental AI. Dental is an area that we're seeing a lot of growth in. It's an area of healthcare that is truly being democratized. There's a lot of people don't have access to good dental care, and AI is taking the top dentists in the world and kind of compressing them, if you will, into the knowledge of the model, which is being made available to the bottom 80% of the planet that would normally not have access to the best dental care in the world, or not even close to that. However, it's a tall order because you have different populations, you have different ways of potentially solving this problem of identifying caries, and then you have different imaging modalities. You could have this is an OPG image, but you could also have an OCT. This is a CBCT. This is a dental CT scan, which will expose the 3D structure of teeth and expose any missing ones really easily. Or you could have an intracam. I'm not going to stay on this image for too long because it's gross for some. But there's many ways of obviously identifying something. But the other thing is that there's many ways of potentially labeling this image. If we want to identify only caries, do we still want to segment the teeth for some reason? And in many cases, this might still affect the model performance by adding one class in a positive way. Do we want to identify classes that can usually be confused by caries as their own thing, such as fillings? And one of our goals is to make this as easy as possible. It needs to be done quickly. So we are trying to throw away the concept of having to do a lot of clicks for creating training data and going for truly automated and scalable training data automation with humans just doing the verification at the end. You can see a side-by-side comparison of kind of where we were when the company was newly founded, where we are today with tools that basically are able to generalize to any object and just create tons of labels using often regular humans. And in terms of use cases that we're seeing, and this is a bit of a tease of something that we could potentially do in a further meetup of the many use cases that are emerging today in CV. Retail is obviously one of the most common ones in which you have different store openings, different products. Imagine the number of products that a large retail chain will stock can sometimes be in the millions. And so how do you identify them all and how do you version control them all? This can happen in small stores to very large ones. In animal husbandry, it's actually one of the coolest use cases, I think, because it tackles both environmental problems as well as really interesting scientific ones This is a set of chickens by a company called Applied Group or Optifarm here in the UK. There's 500 of them. And this actually shows the need for scalability in a lot of these tools. Displaying 500 polygons at the same time, moving around on, say, a web browser is no small engineering feat. So we wanted to make sure that this could be easily smooth and scalable. And one of the cool things is that this is a behavioral understanding in real time. The chicken that are marked as red are eating, the green ones are not doing anything interesting, and the blue ones are drinking. And this, again, is a perfect example of a human in the loop collaboration. There's been 50 images labeled by a human. The rest of them were auto-labeled by a model and then corrected by a human afterwards. And this is the result of it running in production afterwards. And there's only a few examples that would be sent back to the actual system. And we have all the way to examples in microscopy where we see more and more even scientists that are able to create their own deep learning models on their own with less and less machine learning experience to do simple things like cell counting. And then obviously pro deep learning teams that are creating truly groundbreaking stuff in cancer research, in digital pathology, and in many areas of life sciences. Personally, one of the things I'm most excited about, one more step in the direction of making us all live longer is being able to understand the microscopic world around us, and something that we're always happy to look through the lens of, for no pun intended, as well as healthcare. We are currently the leading platform in the healthcare space, and almost a third of our business is in that area. And one of the reasons is we handle the images in their native format directly from medical scanners and try to really contribute to this medical loop that is happening in the healthcare industry that is booming in terms of the amount of training data they need to handle. And especially, it is probably the most data-centric of industries because the subsets of training data are really complex. You have population bias, instrument bias, that is crucial for the performance of any type of model. All the way to environmental cases. This is a stock video, as you can see, displaying a solar flare, and we're seeing an increasing number of them. And just the fact that we can facilitate the creation of the training that they need can help a lot of teams go in the right direction and eventually deploy these in production. One of the most common cases in all of computer vision is manufacturing defect inspection, been there since classical. And in this case, this is from a company called IntelliScience. And these are French fries from a very popular fast food chain that you've all eaten at. And they have black defects that are being identified in real time. In this case, from a smartphone. So there's myriads of things that the kind of data centricity of things is starting to affect. One more that we have seen an enormous amount of growth into recently is in document processing. Classical ML has tackled it through OCR. We're now seeing deep learning approaches that are understanding any layout, and they're understanding key value pairs in this layouts. And the challenge here is that tackling any layout doesn't just mean throwing the kitchen sink at your training data sets, but still being able to rank them and folderize them automatically based on the specific layout that they appear in, because they might come from different customers. And the extracted training data, for example, the shipping number of a specific customer should be easily queryable and searchable at scale. And the scale of some of these documents that are processed is usually in the several millions per month. So it's a far greater amount of data that you normally see in autonomous driving and even healthcare. So huge amounts of data, kind of low impact in many cases because it's receipts, but the kind of by deep learning companies in the spaces covers, in this case, several millions of labels happening every single week. And that takes us to kind of a conclusion of where we're seeing the space going. There's increasing complexity ahead of us. There's many, many more image formats that are appearing. There's many more native formats. We now support 3D CT scans, ultrasound in various modalities, including the measurements that come with them. But we still face challenges in being able to collaborate with external tools in many cases because this is maybe an appeal to the community. There aren't good universal standards for annotation. We use a standard JSON format that works for most cases, but obviously sometimes we get formats from competing platforms or formats from certain academics group that look nothing like something that could be compatible or cross-compatible with other formats out there. So one appeal is let's find ways of being able to work together by making more interchangeable label formats that can refer to an image, which could be a video, an image sequence like the one on the top right, a 3D sequence, or even just a document with multiple pages. All of these can technically be using a very similar labeling schema. And I would like to conclude it onto this and move on to questions. And thanks so much for listening in.
Sweet, man. Really cool to see all of this and all the work you all are doing. I will start out the questions, but I would love to hear everyone else and their questions too. I am willing to bet you got a lot of MLOps stuff going on with V7 behind the scenes. Can you tell us a little bit about that?
Yes, so kind of V7 has an MLOps system within itself, and that's it's kind of where we spend the majority of our engineering time. One of the toughest things, if you look at the landscape of what one would call labeling tools, what's differentiated us from the beginning was that we spent this enormous amount of engineering hours in creating a dataset management system. And one reason why we picked Elixir, for example, as a program language is so that we could easily create all of these real-time changes to a data set that is forever reversioning itself and forever changing in terms of the labels within them, in terms of assignment of one image to another user, and in terms of the tags that actually are associated to these individual items, which today they're no longer just images, they're actually items because you could do machine learning on a collection of tweets, for example, not just a collection of pictures. And I think a relatively boring comparison to this is CRM, where you have Salesforce with all of your contacts and parameters within them. But unlike that, then you need to sometimes make these bulk extractions of millions of these, and then being able to send them directly into PyTorch for training. And sometimes you have several models within V7 that you want to switch on, and then switch them on so you can manage a workflow, because 10,000 is added to a specific data set, or sometimes one image is added to a data set. So we need to switch on a model, which means requesting a GPU to be switched on, and that whole model orchestration system. And that model is on for 1 minute, processes that image, and then switches that GPU instance back off so that we save the customer money. So yeah, there really is a whole lot going on. Happy to kind of go into the weeds of those components.
Yeah, well, you're deploying computer vision models, right? Like with V7 to when someone is going through and labeling, I imagine that you're using a computer vision model there.
Yeah, we have several of them pre-deployed, and they tend to either be class agnostic or they tend to be specialized in one domain, such as reading and extracting text. And then as the user labels, after they've done a few examples, the minimum is 100 per class, they can train a model to do some of the rest of the work for them. And when they trigger that, it's a 2-click experience, it's 3-click experience technically, because they need to buy it. That just starts a training session independently in the background, which then notifies the user when the model is fully trained, which is usually, say, less than an hour on the first run. And then that model can be used as a tool to continually label the data.
Yeah, it's a little meta that you're using a computer vision model so that someone can train their computer vision model.
Yeah, pretty much. I think the hard thing is to avoid garbage in and garbage out. But I think that's what the human is there for. You're effectively a mentor of sorts of your models when you're creating the training data.
Mm-hmm. So talk to me about a few challenges that you've had so far, whether it's within V7 or when it was with the business side of things, or even more interesting, I think, to everyone that is here listening, probably is like when you were putting things together behind the scenes, all of this engineering resource that you talked about and all of the time that you were putting into creating this product, like what were some hard lessons that you had to learn? What were some challenges you went over?
I think probably if I had to look back, the thing that I would suggest to myself is to take more shortcuts. We have an excellent engineering culture at V7, and in large part, this is thanks to my co-founder, Simon, where we have shipped stuff that is really, really robust. At the cost, however, sometimes of making a lot of the stuff internally from scratch. And we would be a wealth today if we had taken shortcuts and used a lot more third-party tools in the early days. On the other side, it allows you to really take control. So this is stuff that is paying off in troves today, but nonetheless, it still was one of the harder things, is creating everything, data set management system, our own model orchestration system, our own training pipeline. We're not using any of the major cloud provider tools for training models. It's all done natively in PyTorch. And probably that's something we could have avoided a little bit, maybe just used it for critical things and focused on the things that the actual business had to take care of. Nonetheless, it's not something that I'm regretting right now. It taught us what we know now, and it also got us an amazing talent in the company that really wanted to sink in their teeth into hard problems.
Well, so knowing that, now as you go forward, are you going to bring on third-party tools, or are you going to continue with this ethos that you've developed?
For new things, absolutely. I think one of the difficult things, and this is something that every AI founder experiences, where do you want to be number one at? What is the turf that you really want to capture and control? And it can't be everything. Even though V7 touches a lot of things, it touches on model training. We are not the world's best model training tool. We're an extremely convenient one, but it isn't meant to create the world's strongest model. It's simply made to make it as easy as possible, and then you can plug in the one that you train on, on your own internally. The same might go for quality, for example. Is something that we do a lot of in assessing dataset quality, but there might be startups out there that focuses solely on quality, which are much better to be an integration into V7. Another area that we don't do at all is 3D LiDAR right now, and that's been by choice. We thought if we did do 3D LiDAR, our product love and attention would shift away from the pixel-based stuff that we're really, really good at, because it's a completely new venture and a completely new dimensionality. And as such, we are looking into integrating into third parties that would even in some cases be competitors to V7. What's pretty obvious is that the space that we're in is really vast, and that there's more than enough for everyone right now to capture within different industries and within different regions of the world. What I'm going to be focusing a lot in 2022 is in trying to create a few bridges between the tooling that is really working out in our space.
Awesome. So if anyone has any questions, feel free to throw them into the chat, or raise your hand even if you want to get involved. I've got another one for you. I know that we wanted to touch on how you're thinking about training data, how things, when it comes to training data, what I would love to know is what you've seen since you started V7, right? Like you said, the company's 3 years old, and it feels to me like there's probably been some evolution there. How do you feel? How do you feel about that?
So to answer a pointed question, if you want to reach out to get a demo, it's v7labs.com, and then just press the button in the middle. And I'd be happy to kind of jump into a demo, show some parts of the platform. However, best thing is just the website is also full of examples of the tool being used in real time, so you can actually have a gander there. And to get back to your question, our journey has, I think, no company in our space outside of investor pitch decks has had a an extremely straightforward journey because the space has evolved so much in 2015 or so until now, and AI startups really started to pop out everywhere. For us, we've always been pretty much hell bent on this mission of creating this one engine to be able to solve any task that you throw at it. Any task that you configure on V7, you should be able to solve it through the use of AI models. And the thing that's evolved a lot was in understanding what training data actually is. We started as a tool where you kind of throw data in and then you apply bounding boxes to it or polygons or whatnot, and then you can train a model in a click, into something that's a lot more enterprise friendly and that is focusing a lot more on flows of data that continuously arrive and they have to be processed by an engine that is sometimes made of multiple components. And we have a few product releases in early 2022 that are going to really double down on that concept that I'm really excited about. A few other things is we've related stuff, so running things on the edge, and that was pretty challenging because moving things from cloud to edge right now, the tooling is a mess. The compatibilities are really hard. We've gone the whole route way too early on and trying to deploy V7 on-prem in some cases, and that's again something we now offer to a large degree, but doing it early on as a software startups is never a good idea because it just ties up all of your time. And a lot of it is just building instinct on which industry is going to and which use case is going to really skyrocket in terms of how much AI is going to contribute to it, and which ones are just cool demos that don't turn into much. And I think we're still in a world where with a lot of cool demos they use deep learning, but for every 3 cool demos there is one really, really world-changing use case. And I think that there's going to be more and more as we go. I think a lot of them are cool demos right now because the costs are still high of developing them.
And by costs, you mean just the full cycle of the machine learning process, or is there other costs that you're talking about?
I think when it comes to startups, they have expectations that they are in a $1 billion market and that they can kind of raise money when they've made, let's say, the first $500,000 in recurring revenue. And there's some use cases where, like, even thinking about how to make $1 million in recurring revenue is a head-scratching problem, where we see a lot of early-stage startups popping up. So I think it's like, how much is someone going to be willing to pay for something that identifies X, Y, and Z because it has AI? The best advice is to kind of look at traditional industries and how they're processing a specific piece of data, and then AI can just make it faster and more accurate. And then are those gains enough? There's also things where AI can make a difference because it exists, something humans could never do. And creation, for example, with GANs and with the stuff that the guys at Runway ML are doing, which is a completely different world from the one that we're in perception. But I think that part is still maturing. A lot of creation tools with AI are still a little bit crappy, but it's one that I'm super excited about seeing from the sidelines.
Okay, so I've got one last question and then we'll finish it off unless something comes through the chat. And you mentioned that you stayed away from LiDAR, and that was a big decision probably on your part. And I imagine you all talked about that for a while on, do you want to go towards that area, especially with AVs becoming so popular and becoming something that is a huge use case that has money behind it. What was that conversation like, and how did you ultimately come to the decision to say no, which I think is amazing that you did say no, because as many have heard, right, it's not what you can say yes to everything and then you spread yourself too thin. What you really have to be good at is saying no to things. So how did that conversation play out?
Every company in our space has a danger of becoming overly dependent on humans as opposed to code and software. And the danger of supporting too many different modalities of data early on, so doing text, audio, images, LiDAR, is that you actually don't tie them together through an elegant software architecture, but you tie them together through humans that learn how to use different tools, and they're actually all independent pieces of software. And this is unfortunately something that happened to other companies in our space, and they're now paying a ton of technical debt, and it slows down the ship significantly. And you can't rebuild a ship while it's already in the water. So I'm a reductionist at heart, and I think that the perfect tech company is Google search. If I had to like name one tech company that is almost like quintessentially perfect, a hedgehog, if you will. It has one bar, and it delivers the content, and it produces the money by just having one text bar. It's so elegant. And we wanted something that was a lot closer to Google search, where we could create an engine that effortlessly creates value, whilst at the same time doing research and stuff that really, really pushes forward humanity. And the way to do it was to focus on doing one thing well using one base system. So in this case, the pixels are our atomic unit. And I feel like in LiDAR, we aren't quite there yet. So we're looking into integrating third-party tools so that our customers can label 3D LiDAR. But I don't think that the future of 3D annotation has found its home yet in the current way 3D LiDAR is produced and labeled. I think it's elegant enough. I would like to see more discussion on that as well, especially at CVPR or NeurIPS or the other conferences. Yeah, I just feel like it's an inelegant solution right now, and one reason for not going toward that.
Excellent.
And business-wise, yes, it's really big, but so I think it's also it's not a sleeping giant. It's a very loud giant because it's made of very loud machine learning companies, i.e., all the autonomous driving companies that are really loud because they need to attract fantastic talent. So I think there's other cases like the receipt transcription is bigger than autonomous driving for when it comes to the training data side, but it is just extremely dull. So people don't talk about it, but it's out there. It's huge.
Nobody cares about that. I want to get taken home by a car that drives itself when I'm drunk, rather than can somebody take this receipt and put it into the computer. That's very true.
But you know what? I hope that if I ask you this question again in 10 years, that you're going to say that both of them are lame, because I feel like that's kind of one of the purposes of AI, is to make magical experiences so magical that we just get used to them.
And we take it for granted.
Yeah, totally.
Well, thanks for coming on here, Alberto. This has been a super interesting talk. I really appreciate the time. And I've got nothing else to ask. If anyone wants to reach out to you, you are in the community, so feel free to reach out to Alberto on there. And I think that's it for now. Next time that I have you on, I promise I will do a musical intro. I know that we did not do that this time, but you have a IOU from me. So we'll have that for next time. Thanks again, man. I really appreciate this, and hopefully everyone enjoyed it. Reach out to Alberto if you have any questions. We will see you all later.
Thanks, everyone. Thanks for coming by. Have a good one.